Unit 6, Lesson 1, Inheritance. Well, this is one of the few times that it's fairly specific as to what it means. You're inheriting something. You're getting something from a parent. In computer science, we have a way of reproducing, so to speak. Our classes can have children. Our classes can have children, and their children can have children, and their children's children can have children. However, it's a little bit different than the biology in that biology requires 2 parents, and computer science it only requires 1. So we need 1 class can have a child. So think of it as single parenting. 1 class, 1 child. So let's see what this all entails. We can have this book class that we built before. And suppose we have a special kind of book called a children's book. It's very similar to a book in that it has a title, it has an author, it has a year, but there's some special things about it. So the parent is kind of generic. It's like the most generic version of a book you can think about. Whereas the child is a specific kind of book. So what we have to do is we have to tell Java, listen, we want this new class to be just like the book class. I want every feature that the book class has. And then we're going to modify it a little bit. We're going to change some things to make it work better as a children's book. So let's take a look at what we're going to do. So first, we're going to define our class, children's book. Much like we defined in book, we said public class book. But now, we're going to add in this command here that says it extends book. So it is an extension of book. As soon as we write this command, Java says, oh, okay, and takes a link. It's not a hyperlink, but it takes a link, sort of, to every method that exists in book and every piece of data that exists in book, that class, that blueprint, and says, all right, that's now in children's book. Children's book now has the same methods and the same data as book. You don't have to write them. In fact, you could stop right now and children's book would function perfectly-ish. We have one thing we have to do. The one thing that we can't get away with not writing is the constructor. We have to write the constructor for children's book. But that's actually pretty straightforward. We have our generic constructor, this. We've talked about this before. So if they don't do an author or a title, we have a generic constructor called this. But then we do something very interesting. Down here, we have a children's book constructor, which is kind of our main constructor. And we have our string with our title, our author. We're adding an illustrator. We're adding in a new piece of data. So up here, you can see we added a piece of data called illustrator. We don't need to talk about author. We don't need to talk about title. We don't need to talk about year. We get that all from book. So we don't need to write that. That's already there. So this can become a little confusing if you don't have the book class in front of you. You need to have the book class in front of you almost at the same time to see what you're inheriting from book into children's book. So we're adding in the illustrator. Then in this constructor, we have a new command. It's called super. Super refers back to the constructor of the parent. Super refers back to the constructor of the parent. So it's much like the word this. It's a contextual word. When I say this, it refers to the object that I'm in. So when I say this, it refers to children's book in this circumstance. Here when I say super, It refers to the immediate parent that this extends. So it refers to book. So we're calling the book constructor. And we're adding to that the title, the author, and the year. And we have to add in the illustrator now to fill in that data for our children's book. So what's happening here, and this is a little weird, there's a private variable called title, but we don't have it written here. It's inherited. So you can almost imagine it's written in invisible ink inside of children's book. It's there. You just don't have to type it. But it's there. So there's a variable up here called private string title. You can't see it, but it's there. There's a variable up there called private string author. You can't see it, but it's there. There's a variable up there called private int year. You can't see it, but it's up there. We also have the same constructors. We have the book constructor. It's in here. We just don't have to type it. Java knows to go back and look at the book class and say, hey, all those methods, they're all in this. It's Prego. We put it all in there. It's like the sauce. Right? Prego, it's all in there. There's also the set title method that we wrote in book class, the set author method that we wrote in book class, and the set year method that we wrote in book class. That's all in here too. We just don't see them. So it helps to have the book class open at the same time so you can see all the data and all the methods that apply to both. So if you were to list all of the methods that children's book has access to, and I did that in air quotes for those in the video, you would have book, book with a title as a constructor, book with a title, author, and year, set title, set author, set year, ToString. All of those exist inside a children's book. You just can't see them. Plus, children's book, and children's book with this signature that has a title, an author, an illustrator, and a year. So there's a lot of methods in there. So when I run this and run some driver code for this, I can create a new children's book, give the life and times of a math teacher, Thomas McLaughlin, illustrated by Walt Disney. We were really close. And it was done in 2015, or 13, whatever that was. And then I can do system.out.println B. I didn't write a ToString method. I didn't have to. It was already written inside of book. I already have that. I don't need to rewrite it. And it prints on the screen everything. The one thing it doesn't print out, though, is the illustrator. It doesn't print out the illustrator. So I don't know who that was because it's not part of my ToString. We're going to have to fix that. Because I should print out the illustrator for a children's book. The children's book ToString method should print out the illustrator. So we're going to have to work on that. One housekeeping note. When you have this open in Dr. Java, you need to have open all three files. There are other programming environments. There are other ways of doing it. You could write an include as a library, and it would have to know where the path was to find it. But Dr. Java makes it easy. You just have to have the files open. So you have to have the book class open, the children's book class open, and of course some type of driver file to run the whole thing. So each class becomes its own file. Do you have to do that? Could you have one file that has all the classes in it? Sure, you could, but that's messy. They do that a lot of times on the internet when they're doing web design. It's called minimizing your code, so it takes up less space on the server. Space always becomes a priority, so they shrink it and take out all the spaces and make it one big long line of text, all run together, and all one file. called minimizing it. You'll find like in your folder for HTML, if anybody does any web design, there's like a min.js file. That's the JavaScript minimized file. It could be it could be 50 files all condensed into one file. And again, they do that just for the sake of minimizing things. It also makes it harder for people to steal your code because they can't read it. You know, it becomes a pain. Oh, we have the parent book, one parent and their single child, children's book. Child inherits everything. The classes are linked together. The child would inherit all the properties and methods of the parent class. That's the relationship. In fact, often in computer science, we will draw diagrams like this. They look a little bit different, but they describe all the relationships of all the different classes together. You know, which classes are parents, which classes are children. You could have children's children, you could have more than one, you could have a child that actually inherits multiple classes. So like the analogy of parent-child kind of falls apart if you have 8 parents. But you could, right? We could have a child that extends like 8 classes. And we get all of the methods and all of the data from those 8 different classes. And would all pull into that one child. So the analogy falls apart a little bit, but the inheritance still works. So here's a blown up version of the code in case you couldn't see it in that teeny tiny little example. But we have here our public class children's book. It extends book. This is the header of the class. When you're extending a class, it's similar to every other class, except it has this extra command that says extends and then lists the classes that it's extending. When I say classes, you can have more than one. You would just put a comma and list all the other ones that it extends. Okay? Then we have our constructor, children's book, very simple constructor. I took out the other constructor just for this short example here. String, title, author, illustrator, year, title, author, illustrator equals I. And up here, there should be a piece of data that's missing. It should say private illustrator up here. Children's book is a child of book. So, what if we go a little bit further? What if the children's book had a child? And we called it board book. You know, you ever see those children's books that are cardboard? It's different than a regular children's book. There's something special about that. So we'd have to go ahead and say, let's take this a little bit further. We can extend this even further. So the super method calls methods and constructors. So think of it as a reference to the parent class. If the parent does not have that method, Java goes up the ladder to the next parent. Let me say it again. If the parent doesn't have that method, Java goes up the ladder to the next parent. So if we go back a slide to the board book here, and we call set title in board book. I didn't write a set title in children's book, did I? So if I use super in board book, Java goes up here and says, all right, is there a set title up here? Nope. Okay. Let me go up to here and look. Is there a set title up there? Yep. So that's what I'm going to use. I'm going to use that code. That's the set title I'm talking about. So it goes all the way up the ladder. So you don't have to rewrite any methods. They get inherited all the way down the line. Which if you have multiple, this is where it gets complicated. This is where you start needing a diagram. If you have multiple generations, the bottom generation gets everything from every generation that came before it. So it becomes a little complicated. You need to have every class in front of you to get the method list. And you don't want to look at all the code. you just want to look at what methods are there. So then we start getting our diagrams not just with the names of the classes, but also what methods they have and what data they have. UML diagrams. That's what they're called, UML diagrams. They're also called other kinds of diagrams, but a UML is what I typically go with. And in a UML diagram, you list the class, the methods, and the data. That's really what you need. The class, the methods, and the data. And then you draw out the inheritance. You know, what class is the parent of what class? And you kind of draw it out as a link, and you follow the path. That way you can see what methods in board book do you actually have access to. And that becomes very helpful. So as we go through, if you get a more complicated structure, rather than just looking at the code and sorting through the methods that way, you make a list of all the methods that you're getting plus all the data. There's also this thing I like to call the originator. It's the original parent. Nothing's above it. It's called the object class. Everything in Java automatically extends the object class, so we don't write the command. Theoretically, we should say, every time we create a class, extends object. But we don't have to. It's automatic. So I've been saying now for a couple weeks that we have this ToString method. And if we don't write the ToString method, then we get this garbage back, which is, you know, information about the reference and things like that. It's some just very high-level stuff that we don't really need to interpret, but it's there. The ToString method lives in the object class. So we are getting automatically, we're inheriting the ToString method from the object class every time we create a class. So everything can be treated as an object. So if we think about in terms of relationships, we can think about our board book and our children's book and our book, and then up here, oops. Maybe I won't be able to write. So we have the book class is a child of object. An object has a method in it called ToString. But so does book. We wrote a new one in book. And it overrides the object ToString method. It replaces it. So we can write new methods that replace the methods that the parent classes have. So we replace the ToString method with a new one. So when BoardBook calls ToString, first, using the super, it looks at children's book. Children's book doesn't have a ToString. We're going to fix that later, but right now it doesn't have a ToString. Then it goes up to book. Book has a ToString, and it stops and uses that ToString method. Even though object also has a ToString, it stops here because that's the first time it found a ToString in the chain. If this didn't have a ToString, I'd go back up to object. So we always have access to the ToString method. It's just if we use the object level ToString method, we're not going to get any really good information. Okay, so that's basically it here so far. I mean, we got more to do with this. We haven't started actually writing these classes yet. We just started talking about the references. We talked a little bit about code, but we haven't dove too much into how do we call methods using this super reference. We talked about how to call the constructor using the super methods, but how do we call other methods like the set title using the super method? So we still got some things to talk about in this. There is a exit ticket and an assignment in this. Let's take a look. So here is the exit ticket. You can work on the exit ticket. You also have a practice assignment. It's not a coding assignment. It's some exercises to look at inheritance. It's a PDF. So if you open up the PDF, okay, we can see some relationships. And they ask us some questions about those relationships. So we're not really writing code right now. With this, we are just talking about relationships. So red is extending green. So to kind of give you a hint of what direction is going here, we have to remember that red now gets all of the methods that are inside green. So for example, they have the Peabody method. That's there. It also has data called crunch and a double MM and a long XX. That all exists inside of class red as well. So just, you can put it into the written submission, the answers to these questions. There should be 11 of them. So just write in the 11 questions. By the way, this down here, super.calc, is how you would refer to the calc method in the parent class. So if we wanted to refer to the set title method in board book, we would say super.setTitle. So putting that super modifier in front of it tells Java to go and look in the parent class for that method. So if I wanted the setAuthor method, I would have to say super.setAuthor because I didn't write it in board book. It's inherited from book. So if I want to use it, I have to say super.setAuthor. If I want to use the constructor, I don't have to say anything else other than super and send the correct parameters or correct arguments. So that's it for the lesson. Do the exit ticket and the practice, and never stop coding, and we'll see you next time.